Okay, so in this video, I wanted to make some clarifications on some things we've talked about in the past, and I want to start with the action potential for pacemaker cells, specifically with the funny channels. So, in discussion a few weeks ago, when we talked about the funny channels, we talked about how they are a non-selective cation channel, so they will let calcium and sodium in and potassium out. So the change that I want to make is that the funny channels actually do not move calcium. So calcium does not move through the funny channels. But the other things are still correct. So sodium does still move in and potassium still moves out. The net result is the gradual depolarization here from the funny channel. So that's the net result. Sodium moving in, potassium moving out. So the reason why I said calcium moves in during this phase is because of a very small detail that I missed. So on that white line, that gradual depolarization, those funny channels open up at the start. And then right around here, the funny channels will close. So those red lines indicate when the funny channels are open. So right before it reaches the membrane threshold, those funny channels close. And actually what happens is right here, we get calcium channels opening. And then calcium is responsible for that last bit where it goes up right here. So calcium is responsible for that tail end. Sodium and potassium are responsible for that first part of it. So in discussion, when I told you that calcium and sodium are moving in, that is still true technically, but calcium's not actually moving through the funny channels. So calcium is not moving through funny channels, it's sodium and potassium. But towards the very end of this gradual depolarization, we get those calcium channels opening. So I've pulled the autorhythmic cell slide from Ian's lecture, and that's what is shown here. And it's really easy to miss. So we see here that from this part to this part, we have net sodium coming in. And then starting from this second red line, we get calcium moving in. But in discussion, I told you that from that whole part, it's sodium and calcium, which is still technically true, but I just wanted to make the clarification that calcium is really only coming in on that last little bit right before membrane threshold. So just to recap, funny channels, that's not how you spell funny. Funny channels move sodium in and potassium out. That's the role of funny channels. Okay, so when we want to alter the heart rate through funny channels, we use our parasympathetic and sympathetic nervous systems. So here on this side we have parasympathetic, and on the right we have sympathetic. So we see that they target the autorhythmic cells. They both target the autorhythmic cells. And the parasympathetic acts on the funny channels by increasing the permeability to potassium. So more potassium exits the cells. And then it decreases calcium influx. So that last little bit of the action potential here, that calcium influx has been slowed. But the big part is the potassium efflux. The potassium efflux has the greater effect on slowing heart rate. But both of those things do happen. And then on the sympathetic side, it is still targeting the autorhythmic cells. It's targeting the sodium through the funny channels and then those calcium channels as well. And that is norepinephrine or epinephrine that's doing that. So the main clarification I want you to take away from this is, again, the role of the funny channels. and what ions they actually move. Okay, the second clarification I wanted to make was on EKGs. So just as a reminder, EKGs record the electrical activity of all of the cells in the heart, so the autorhythmic and the contractile cells. Now, when we talked about the pathologies of that, two of them that we talked about were the fibrillations. So with fibrillations, we talked about it being an incomplete depolarization. And that is true. And when I told you kind of conceptually what's happening, we talked about if the chamber is not fully depolarizing, then it won't fully contract. So with fibrillations, the contractions of the muscles or the chambers, they are kind of asynchronous. The entire chamber is not contracting together. It's not contracting all at once. So with fibrillation, the chambers would not have the smooth rhythmic contractions that they usually have. Some areas of it will contract while others relax, then other areas will contract while others relax. You don't have a synchronous contraction. But that's not to say that you have no contraction. So the absence of contraction or no contraction, that is asystole. Asystole is not the same thing as a fibrillation. So with fibrillation, it's the asynchronous contraction. So the contraction that is not rhythmic anymore. Asystole is a full lack of contraction, so no contraction whatsoever. With fibrillation, it is still trying to contract, it's just not doing it in a coordinated fashion. So that's the thing that I wanted to clarify with fibrillation, is that it is still contracting, it's just not doing it very effectively. So it's not being an effective pump anymore. Okay, that's the only other clarification I had. So this is a pretty short video. Good luck on your exam tomorrow, and I am always available to answer your questions through email.